between locations over time. Nutrients describe many different elements, especially nitrogen and phosphorus, that plants draw from the soil, air, and water. They facilitate chemical reactions and serve as building blocks for plant material. Once they are collected by the plant, these nutrients are consumed by animals, transported elsewhere, and redistributed back into the soil. They are then reused by new plants.
When you look at this landscape, 80 to 90%, if not more, of the nitrogen that's in this ecosystem, say this small watershed that we're in, is tied up in these trees. In the oaks, the live oak, the blue oak, the foothill pine, a lot of nitrogen and carbon is tied up there. When the herbivore comes along, either a natural herbivore or a domestic herbivore such as a cow, they speed up this process of making plant nutrients available. Basically, they consume the plant, and via digestion of the plant in their rumen, they make these nutrients readily available in their feces. The vast majority of feces from herbivores is deposited in the uplands throughout rangeland, and this can be a good thing because you have then readily available nutrients across this landscape available for further plant growth, to support microbial activity in the soil and other important ecosystem functions. So if we look over here, we can see an old fecal or a urine spot from earlier this winter that as this vegetation has grown, it's responded to that available, probably nitrogen in this case, and has sequestered it. So we have vegetation that's much greener, so you have the green up response, just like you'd see on your lawn at home if you were to fertilize it. We also see greater productivity relative to the surrounding area that didn't receive that fecal or urine contribution from the cow. For the small percentage of fecal paths that are deposited in or near a stream or a wetland, this can be problematic if that stream is at or near its capacity for the nutrients that are being contributed. If a stream has excessive nutrient levels, then it will basically grow an excessive amount of vegetation within the stream, which will utilize oxygen and deplete the amount of oxygen that's available in the water itself to support aquatic animals that require that oxygen.
The rich content of feces is a product of all the microorganisms that live there. The vast majority are harmless, but a few varieties, called pathogens, can cause us to get sick if we ingest them.
That these pathogens excreted by livestock can enter water, could contaminate drinking water thus, and if that water is used to irrigate, could contaminate crops. All of these things are site-specific and they are pathogen-specific. Certain pathogens like Cryptosporidium parvum, Giardia, which are protozoa, cannot replicate in the environment. So their fate is going to be very different from some of the bacteria, such as E. coli, which can replicate in the environment once deposited by a cow. And so there's some big differences in the fate and transport, thus the risk, and the management options for these various pathogens.
The final process is